Most people think the strongest building materials on Earth come from giant factories, poured by massive machines, mixed with chemicals most of us can't even pronounce. Concrete, steel, industrial cement. We're told strength has to be expensive, complicated, engineered. But what if that wasn't entirely true? What if there was a liquid, sitting quietly on ordinary hardware store shelves, that could turn plain sand into rock-hard blocks tougher than some forms of concrete? No giant machines, no roaring furnaces, just sand, and a strange chemical reaction that almost feels impossible the first time you see it happen. Because here's the part that makes people stop and stare. A pile of loose sand is one of the weakest things imaginable. You can crush it in your hand, kick it apart with your foot. Yet under the right conditions, those same grains can become something shockingly solid, dense, durable, weather-resistant. And once you understand why it works, you start wondering something uncomfortable. If this process is real, why don't we hear about it more often? Every year, Americans spend billions repairing cracked driveways, damaged patios, broken garden walls, and crumbling concrete surfaces. You patch one section, another fails. Water gets in. Heat expands it. Winter tears it apart. And most people assume there's no alternative because modern construction has convinced us that strength only comes from industrial solutions. Meanwhile, in different parts of the world, people have quietly experimented with mineral-based hardening methods for centuries. Ancient builders stabilized earth using lime, ash, clay, salts, and natural binders long before modern concrete dominated everything around us. And honestly, when I first heard about this idea, I didn't believe it either. The story started with a materials experiment that looked almost ridiculous. Someone poured a clear liquid over ordinary sand packed into a mold. A few hours later, the sand wasn't loose anymore. It had bonded together into a dense, solid mass. Not fake internet magic, not some edited clip, real chemistry. The kind hiding in plain sight because most people never think to question the materials around them. The liquid at the center of this process is often sodium silicate. Some people call it liquid glass, and the nickname alone sounds like science fiction. But it's very real. For over 100 years, sodium silicate has been used in everything from fireproofing to preserving eggs to industrial sealants. Yet outside specialized industries, hardly anyone talks about what happens when it interacts with sand. To understand why this works, you have to look closely at what sand actually is. Sand isn't just dirt. Most sand is made largely from silica, the same mineral family connected to glass and quartz, tiny hard particles. On their own, they slide past each other freely. But when sodium silicate is introduced, something fascinating happens. The liquid coats the grains and begins forming rigid bonds between them. Imagine millions of tiny rocks suddenly locking arms together. What was loose becomes unified. What was weak becomes surprisingly strong. It's similar to the way ice cubes become solid when frozen together. Individually, particles move freely, bond them correctly, and the entire structure changes behavior. Now, does that mean you can replace every skyscraper foundation in America with backyard sand blocks? Of course not. And this is where honesty matters. Internet videos love turning interesting science into fantasy. The truth is more grounded, and honestly, more interesting because of it. These hardened sand mixtures can become extremely durable for specific applications. Pathways, small structures, landscaping blocks, heat-resistant forms, experimental eco-building materials. Some formulations even resist water surprisingly well. Researchers have explored similar concepts in desert stabilization projects, erosion control, and sustainable building alternatives because traditional concrete production has a massive environmental cost. And that cost is enormous. Concrete manufacturing contributes heavily to global carbon emissions. Massive kilns burn at extreme temperatures. Raw materials are mined at huge scales. Transportation costs pile up. Entire industries depend on systems built around centralized production. So when smaller, simpler alternatives appear, even limited ones, they often stay niche because large industries don't shift quickly. Not because there's a secret conspiracy hiding sand technology from the public, but because modern systems are designed around methods already deeply established. That happens more often than people realize. Sometimes the most overlooked ideas aren't hidden because they're fake. They're ignored because they don't fit neatly into existing habits. And once you see how simple some of these experiments are, it becomes hard not to think differently about the world around you. The basic process itself is surprisingly straightforward. Fine sand is packed tightly into a mold or form. Then the sodium silicate solution is applied carefully so it spreads through the material. In some cases, additional hardeners are introduced to speed up the reaction. Over time, the mixture begins to stiffen and cure. The grains stop behaving like separate particles and start behaving like a single object. The tighter the sand is packed, the stronger the final result tends to become. Grain size matters too. Fine grains create denser structures. Moisture levels affect curing. Temperature affects bonding speed. It's less like a magic trick and more like controlled mineral engineering simplified into something ordinary people can actually understand. And what's fascinating is how this changes the way you think about waste materials. Sand is everywhere. Silica is everywhere. Nature has already produced the raw ingredients. The trick is understanding how to reorganize them. There's also a psychological reason people are so drawn to experiments like this. Deep down, many of us are exhausted by complexity. Everywhere you look, solutions seem to involve more subscriptions, more expensive products, more specialized systems. So when something simple appears, something that looks almost primitive yet still works, it captures attention instantly. Not because it's magical, because it feels honest. A man in Arizona reportedly experimented with hardened sandforms to create heat-resistant garden, structures that survived brutal desert summers better than some commercial materials. Small eco-building communities have explored mineral-based compressed earth systems for years because they're affordable and locally sourced. Even modern researchers continue testing silica binders for future construction methods in harsh environments where transporting traditional concrete is difficult, including places you'd never expect. NASA has even explored concepts involving regolith, the dusty material found on the Moon and Mars, mixed with binding agents for future extraterrestrial construction experiments. Because when resources are limited, humans return to the same ancient principle again and again. Use what's already around you. That idea alone changes something in your perspective. But there's another layer most people miss. Some experimenters discovered that adding natural fibers or layered reinforcement inside hardened sand mixtures dramatically improves crack resistance. Tiny fibers help distribute stress throughout the structure, similar to how roots stabilize soil underground. Again, nothing mystical, just understanding how nature already solves structural problems. And still, there are important limitations. Not all sand works equally well. Some mixtures become brittle if ratios are wrong. Poor curing can weaken the structure significantly. Large load-bearing applications require professional engineering and testing. Sodium silicate must also be handled responsibly because concentrated solutions can irritate skin and eyes. This isn't a toy, it's chemistry, real chemistry. And perhaps that honesty is exactly why these ideas deserve attention. Because real innovation rarely looks like the movies. They usually start small, quiet, experimental. A strange observation in someone's garage, a forgotten technique rediscovered decades later, a simple question nobody bothered asking because the modern world moved too fast to notice. What if strength doesn't always come from adding more, but from understanding what's already there? That may be the deeper lesson hidden inside a bucket of sand. For generations, people survived by studying materials closely. Stone, clay, ash, lime, minerals. They learned through observation, patience, trial and error. But modern life often disconnects us from that relationship. We buy finished products without ever wondering how they work. We stop seeing possibility inside ordinary things. Then suddenly, one strange experiment reminds us. The world is still full of hidden potential. Not hidden because someone locked it away, but because most people stopped paying attention. And maybe that's why videos like this spread so quickly. They awaken something older inside us. Curiosity, skepticism, wonder. The realization that even in a world drowning in technology, simple knowledge still has power. So the next time you walk across concrete or kick at loose sand on a beach, you might see it differently. Not just as dirt beneath your feet, but as raw material waiting for the right idea. And honestly, that idea may be more valuable than the blocks themselves. If you've ever come across strange old techniques, forgotten building methods, or simple materials that surprised you, share them below. Some of the most interesting discoveries don't come from giant laboratories. They come from ordinary people willing to experiment, observe, and question what they've been told is impossible. This is VitaNova Health, and sometimes the most powerful knowledge starts with looking at ordinary things a little more carefully.